All right, so here's our last section, which is going to be section 6, solving rational equations. And this actually is something you've already done before. So let me show you like a little example here. So let's say I had this equation right here. So the directions are solve. And we wanted to solve 1/2 plus x over 3 equals 5 over 6. Okay? So this is a rational equation because you have fractions, and we know fractions are rational expressions. Now, the way that we solve this is you always want to find that LCD first. And the reason why you want to find the LCD is so that you can eliminate denominators. That is the key to this. Okay? So our LCD here is going to be 6. So what I'm going to do is I'm going to write 6 times 1/2 plus 6 times x over 3 equals 6 times 5 over 6. And like I said, our goal here is to eliminate denominators. This is our goal. So the first thing you should do then, all right, is when you look at the very first term, 6 times 1/2, is I want you to multiply those two numbers together. Now, the easiest way to do this, like I said, you were focused on eliminating denominators, so just ask yourself, what is 6 divided by 2? And 6 divided by 2 is 3. And I'm going to multiply it by 1 because that's my numerator. Plus, now I'll do the same thing for the second term. 6 divided by 3 is 2 times x. And then on the right-hand side of the equation, 6 divided by 6 is 1 times 5. So in one step, just by knowing the LCD, we've eliminated all denominators. So now from here, we're just going to clean things up. In other words, I'm going to take 3 times 1, which is 3, 2 times x, which is 2x, 1 times 5, which is 5. And now I can solve for x by subtracting 3 from both sides. I get 2x equals 2, and then dividing both sides by the coefficient. 2 divided by 2, we know that simplifies down to a 1x, and 2 over 2 is 1. So in this case, x equals 1. Okay? And if we can just understand how to do that problem, every single problem in this section is going to be done the same exact way. You're going to try to find that LCD first, and then you're going to multiply every single term by the LCD. Let's actually write this out. Steps to solve rational equations. I think this is going to be pretty nice, okay? So like I said, the first thing that we're going to want to do is find the LCD. Second, you're going to multiply all terms by the LCD to, and this is the key, eliminate all denominators. So that's where you focus. Step 3, you're going to solve. Now, these next couple steps here, I'm going to write in red because they are unbelievably important, okay? So once you solve, your fourth step is that you have to check for what we call extraneous solutions. Now, this is something new for us, okay? That's why I'm writing it in red. Check for extraneous solutions. Okay? And extraneous is just a really fancy word for extra. Okay? Now, the reason why we have to check extraneous solutions is because we want to avoid possible zeros in our denominator of the original equation. And those are our steps right there. So step 1, find the LCD. Step 2, multiply all the terms by the LCD to eliminate all denominators. Then we're going to solve, and then whatever answers that we arrive at, we're going to have to check them because we want to make sure they're not extraneous. Okay? So here's an example here of what I'm talking about. This is a very simple one. All right. And it should look very familiar because I just did it. But so we already know in this situation here, x is going to equal 2. But let me demonstrate how to get that, okay? Right there is my variable. It is in the denominator. So I know I'm not allowed to have a 0 in that denominator. So right now I'm thinking, man, the only answer I'm not allowed to have is x equals 0. Because I cannot have 0 in that denominator. So I'm going to like keep that in my mind. Okay? So step 1, let's find that LCD. It's going to be 6. Now we're going to, oh, I'm lying to you. Our LCD is going to be 6x. Okay? So I'm going to multiply everything here by 6x. And watch what happens. Oops. That's supposed to be an equal sign. All right, step 1, multiply everything by 6x. Or, I'm sorry, step 1 is LCD. Step 2, multiply everything by 6x. Now let's reduce, okay? Notice you have an x in the numerator, x in the denominator. This is 6x over 1, okay? So there's an x in the numerator, x in the denominator, so they will reduce. You're left over with 6 times 1 plus, oh, this is supposed to be a 3. I'm sorry. So now 6 divided by 3 is going to be 2. So they reduce. So you're left with 2x times 1 equals, and here the 6's reduce. So you're left over with x times 5. Now from here, clean it up. 6 times 1 is 6. 2x times 1 is 2x. And x times 5 is 5x. So now what I'm going to do is get my variable terms together. So I subtract 2x from both sides. That gives me 6 equals 3x. And then finally divide both sides by 3 to give me x equals 2. Which is exactly what we thought. But we got to remember here, we need to take this number 2 and substitute it back into the original equation. And the reason why we do that is because we want to make sure that when we substitute it back into the original equation, we don't get a 0 in a denominator. And in this case, we do not get a 0. So x equals 2 is a good solution. Okay? And that is how you do every single one of these problems. It's just sometimes that denominator is going to be a little bit different. So let's do another one here. So we're going to solve 1 minus 2 over a equals 15 over a to the second. Now, step 1, let's get that LCD. So my LCD in this situation is going to equal a times a, or a to the second. Okay? So I'm going to multiply everything by a to the second. So I'm just going to write it out here. Now, going from left to right, I get a to the second times 1 is a to the second minus, now a to the second times 2 over a. You got to remember, and I'm going to write it off to the right-hand side here. A to the second is a times a, and then you have multiplied by 2 over a. So one of these a's will reduce. So you're left over with a times 2 equals, now the a to the second in the numerator and the a to the second in the denominator, they will reduce. So you're left over with just 15. So from here, I'm going to clean it up a little bit. A to the second minus 2a equals 15. And what you got to be able to recognize now is that we have a quadratic equation, which means we need to set it equal to 0, factor, 0 product property. So I'm going to subtract 15 from both sides. I get a to the second minus 2a minus 15 equals 0. Then I can factor. I write an a, a minus and a plus. I need two numbers that multiply to give me 15. But they have to combine to give me negative 2. And I know one of the numbers is negative, the other one's positive. So the only way I get negative 2 is with plus 3 minus 5. So plus 3 and minus 5. So now I could take each one of these, set them equal to 0, using my 0 product property. And I get a equals 5 or a equals negative 3. Now, before we move on to the next problem, you got to remember, and I'm going to write it off. I'm going to write it over to the right-hand side. 1 minus 2 over a equals 15 over a to the second. I got to check both solutions, the 5 and the negative 3, and I can do that mentally. I'm going to put a 5 in for a, and the reason why I do that is I want to avoid zeros in my denominator. So I don't get that here with the 5, so I like to put a little check mark next to the 5. And then the same thing is going to happen with the negative 3. I avoid zeros in my denominator, so that's good. Okay? All right. So the next question we're going to look at really drives home this entire section. Okay? So we're going to take our time with it. So we're going to solve m plus 11 over m to the second minus 5m plus 4, which equals 5 over m minus 4 minus 3 over m minus 1. Okay? So the process is still the same. Even though this problem looks more complex, it's not. The process is still the same. We're going to find the LCD. So m to the second minus 5m plus 4 equals, well, we can factor that down into m and an m, a minus and a 4 and a 1. So there's our first denominator. Now, on the right-hand side, you have 5 over m minus 4. m minus 4 cannot be factored. The m minus 1 also cannot be factored. So our LCD, it's a horrible looking D. There we go. Remember, drop it straight down. M minus 4 times m minus 1. So we're going to multiply the entire equation by m minus 4 times n minus 1. Now, just watch how I do this. The key is just to be organized, right? Nice and neat. So I'm going to write m minus 4 times m minus 1, all multiplied by m plus 11 over, and I'm going to write the factored form of m squared minus 5m plus 4. All right, so there's my first term. Now I'm going to do the same thing for the other terms on the right-hand side. m minus 4 times m minus 1, all multiplied by 5 over m minus 4, minus m minus 4 times m minus 1, all multiplied by 3 over m minus 1. Now remember, the whole reason why we needed to find this LCD is so we can clear out the fractions, so we can eliminate denominators. Now, if you go from left to right, just watch, and I'll highlight and then I'll cross out. So left to right, m minus 4, m minus 4, m minus 1, m minus 1. So what I can do here is scratch out all of them. And I'm left over with m plus 11 in my numerator. And I'll put it in parentheses. Equals. I'll do the same thing here. I got an m minus 4 in a numerator, m minus 4 in the denominator. So I can cross them out. And look what's left over. You got a number 5 and the quantity m minus 1. So I'm going to write 5 times the quantity m minus 1. Now you got a minus sign, so put a minus sign. And then you have an m minus 1 in the numerator, m minus 1 in the denominator. So I'm going to cross them out. And I'm left over with a 3 in the numerator times m minus 4. So what looked like a very difficult problem actually turned out to be really simple. It was just you had to find the LCD. Okay? So from here, we're going to clean things up. On the left-hand side, m plus 11. That stays the same. On the right-hand side, I'm going to distribute the 5. So I get 5m minus 5, and then distribute the negative 3. Minus 3m plus 12. Now, if I just take a second and I look at all my variables, so an m, an m, and an m, notice that they're all raised to the first power. So this is a linear equation, and I know how to solve a linear equation. So I'm going to group all my like terms on the right-hand side. 5m minus 3m is 2m. Negative 5 plus 12 is positive 7. Now I'm going to get my m's together. So I will subtract m from both sides. That gives me 11 equals m plus 7. And finally, I will subtract 7 from both sides to give me m equals 4. Okay? Now, remember, you have to check this solution. Okay? So I'm going to write the original problem underneath. So the original problem was m plus 11 over m to the second minus 5m plus 4 equals 5 over m minus 4 minus 3 over m minus 1. Now, I need to check this solution. And look what happens right here. If I put a 4 in for m right there, remember, I'm going to actually put a 4 in for m anywhere I see that letter m. So it's going to go in each one of those. However, I'm really focused right here. And the reason why I'm focused right there is because it's the easiest. So if I substitute in my solution, I will get 4 minus 4, which equals 0. And that is what I'm not allowed to have. So, although 4 equals m looks like a solution, it is not. This means 4 is an extraneous solution. There is no solution to this problem. And that's how fast something like this can happen, okay? The only way you're going to know if you have an extraneous solution or not is you have to check your solution no matter what. Because it looks like, it feels like, oh, this is great, we got an answer. But in reality, we didn't. Okay? Let's try another problem here. Let's see what happens here. All right, so here's our next one. So y minus 14 over y squared plus 3y minus 4 equals 2 over y plus 4 plus 7 over y minus 1. So we're still going to find that LCD. So my LCD, I'm going to write it underneath. Y squared plus 3y minus 4. Well, that looks like it can factor down into, let's see here, y and a y, a plus and a minus. And it looks like it's going to be a 4 and a 1. Now, the other denominators, y plus 4 well, that's prime. Doesn't factor. Y minus 1, that stays the same. So I'm just going to write it here. And remember that LCD equals comes straight down. Y plus 4 and Y minus 1. So that's good. That's a good thing. All right. So I'm going to rewrite this, and I'm going to multiply every single term by the Y plus 4 times Y minus 1. All right, so here we go. Y plus 4 times Y minus 1, all multiplied by Y minus 14 over, and remember, I'm going to write this in its factored form. Y plus 4 times Y minus 1 equals 2 over, Y plus 4 times Y plus 1, Y minus 1, multiplied by 2 over Y plus 4, and then plus Y plus 4 times Y minus 1, I'll multiply by 7 over Y minus 1. Now I'm going to do the same thing that I did in the previous problem. I'll highlight for us. So I got a Y plus 4 in the numerator, Y plus 4 in the denominator, Y minus 1 in the numerator, Y minus 1 in my denominator. So all those reduce. So we'll just reduce them. And I'm left over with Y minus 14. On the right-hand side, we got a Y plus 4 and a Y plus 4. They reduce. I write what's ever left over. 2 times Y minus 1. And then finally, Y minus 1 in the numerator, Y minus 1 in my denominator. So that's going to give me plus 7 times Y plus 4. Now from here, we're just going to clean everything up. Y minus 14 equals 2Y minus 2 plus 7Y plus 28. Group all your like terms first. So Y minus 14 equals 2Y plus 7Y. That's going to be 9Y. And negative 2 plus 28, that's going to be minus 26. Plus 26. Now let's get our Y's together. So I'll subtract Y from both sides. That gives me negative 14 equals 9 minus 1 is 8Y. Plus 26. Next, I'm going to get my constant terms together. So I'm going to subtract 26 from both sides. Negative 14 minus 26 is going to be 40. With a negative out front, because remember, you combine the numbers, keep the sign. And finally here, I'm going to divide both sides of the equation by 8 to give me Y equals negative 5. Okay? Now remember, we need to check. Just don't move on to the next one. All right? So we're going to check this solution. Let me write out the original problem. Y minus 14 over, and I'm going to write the factored form. Y plus 4 times Y minus 1 equals 2 over Y plus 4 plus 7 over Y minus 1. Now, if you want to, you can really get hardcore with this and just make your substitution. And that's 100% fine with me. But remember, what you're looking for is a 0 in the denominator. Well, negative 5 plus 4 is going to be negative 1. Negative 5 minus 1 is going to be negative 6. So you don't get a 0 there. That's good. Negative 5 plus 4 is negative 1. And negative 5 minus 1 is negative 6. So since we never ever get a 0 in our denominator, we are confident that Y equals negative 5 is our solution. Okay? So now I'm going to do a couple more problems, all right? And these problems here will end up resulting in quadratic equations, okay? So let's try this one. So we're going to solve n over 12 plus n plus 3 over 3n equals 1 over n. Okay? My approach doesn't change. I got to find my LCD here. So I know 12, well, that breaks down into 2 times 3. 3n is going to equal 3 times n. And then the variable n is just a variable n. It doesn't factor or anything. So my LCD, and remember, you come straight down with everything, okay? So my LCD is going to be 2 times 3 times n, or 12n, okay? This little LCD technique will always work. The only thing is you got to be organized. So I'm going to take 12n, and I'm going to multiply every single fraction by it. So 12n times n over 12 plus 12n times n plus 3 over 3n equals 12n times 1 over n. Okay? Now the next thing I'm going to do, excuse me, is we're going to reduce. So I'll just keep with theme. I got a 12 in the numerator, 12 in my denominator. So they reduce. And I'm left over with n times n plus. Now, I got an n in the numerator, n in the denominator. So I know they're going to reduce. And then 12 divided by 3 is 4. So I write a 4 out front. And I write the n plus 3, which is my numerator, left over. Equals. All right, so I got an n in the numerator, n in my denominator. So they're going to reduce. So I'm left over with 12 times 1. Now, I'm going to clean this up. N times n is n to the second power plus 4n plus 12 equals 12. So notice here, that's my quadratic term. So I know my technique changes. I need to set this equation equal to 0. So I will subtract 12 from both sides. And now I need to factor. Well, in this case, we do have a GCF. It's the letter n, so I'll factor out an n. And now I have two solutions, n equals 0 or n plus 4 equals 0. The n equals 0 is already solved for. That's good. The other one, I just need to subtract 4 from both sides to give me n equals negative 4. Now, you got to check these solutions. You have to check. So, off to the right, here's the original problem. N over 12 plus n plus 3 over 3n equals 1 over n. So we're going to let n equals 0 first. So I get n over 12 plus n plus 3 over 3 times 0 equals 1 over 0. Now, two things are happening here. Number one, I don't care about the numerator. Numerators are allowed to be 0. It's the denominator I got to be worried about. And look what happens here. 3 times 0 is 0. And you can't have 1 over 0. So I know n equals 0 is not a solution. This is extraneous. Okay? Oops. Now I need to check n equals, what was it? N equals negative 4. So once again, I don't care about the numerator. The only thing I care about is that denominator. And if I just do a quick glance, 12, that's good. 3 times negative 4 is negative 12, that's good. And negative 4 is good. So n equals 4 is my only solution to this problem. Okay? So n equals -4 is the only solution. Okay? And like I said, you gotta check these every single time. There's no way around this. No way around it. You gotta check them. Okay? So what I'm gonna do is I'll do one more. All right, because I always like to do one where it's kind of like a little complicated. There's a lot of factoring involved and stuff like that. Okay? All right, so here's this example. Once again, directions are solved. Now with this one, I'm not gonna like rush through it, but I'm just gonna do the problem. That's it. All right, so here we go. Y over 5y minus 10 minus 5 over 3y plus 6 equals 2y squared minus 19y plus 54 all over 15y to the second minus 60. Okay? Now, step 1, let's get that LCD. So 5y minus 10, well, that's going to factor down into 5 times y minus 2. Okay? 3y plus 6, well, that's going to factor down into a 3 times, and I'm going to write it all the way over here, y plus 2. All right? Give myself a little bit of space. Okay? Now, the 15 y to the second minus 60, you know what I'm going to do? I'm just going to do this over here on the right-hand side. All right, because I know I get an L. I definitely have a GCF real quick. So 15y to the second minus 60. I know I can factor out of 15, so that's going to give me y squared minus 4. And then I got difference of squares, so it's going to be y plus 4. Oh, sorry, not plus 4. It's going to be y plus 2, and then y minus 2. And then last but not least, that 15, that can break down into 3 times 5 times y plus 2 times y minus 2. And if you look, and you're going to see this, and to be honest with you, this happens a lot because we want you to do this. The 15y to the second minus 60, watch when I write this nice and neat underneath. 3 times 5 times, I'm going to put the y minus 2 first, and then the y plus 2 second. So I think you can see that if I come straight down, my LCD is going to be 3 times 5 times y minus 2 times y plus 2. Okay? So I know, I get it. It's a doozy. Okay? But it's just one of those things where it's like you got to just take your time with this. And you all know how to factor. It's just putting everything together to solve. So we're going to multiply every single term by, by 3 times 5 times y minus 2 times y plus 2. And we're going to write out each denominator in its factored form as we do this. That way you can easily see what reduces and what doesn't. All right, so here we go. Let's take our time with this. Hopefully I can write nice and neat. 3 times 5 times y minus 2 times y plus 2. Before I do anything, I just want to copy this so I don't have to keep writing it. So I want to multiply this by y over 5 times y minus 2. Okay? Minus, now let's see how good I am at this. All right, I don't like that, but I can do it like this. There we go. Oh, look at that. That's a beautiful thing. All right, so 3 times 5 times y minus 2 times y plus 2. I'll multiply by 5 over 3 times y plus 2 equals, all right, last time for this. Uh-oh, what is going on here? All right, well, I thought I can get away with it. Obviously, I can't, so I'm just going to write it again. 3 times 5 times y minus 2 times y plus 2, all multiplied by 2y to the second minus 19y plus 54, all over 3 times 5 times y minus 2 times y plus 2. All right, so let me zoom out here a little bit so we could see everything. All right, like I said, this one, tough. However, let's just take our time. So before we move on, let's just recap what we're doing. I'm taking the LCD and I'm multiplying every single term by my LCD. Also, I factored every single denominator, and I did that so I can quickly reduce anything I need to, okay? So, with my highlighter, we're going to go ahead and start reducing everything, okay? So if you notice, I'm going to start on the far left, and we're going to move to the right. So here we go. In the first term, there's a 5. Here's a 5. Y minus 2 and a y minus 2. So whatever I do not have highlighted is what I'm going to rewrite. All right, so let's scratch out the 5. Scratch out the y minus 2. And then we're going to write 3 times y plus 2 times y, okay? Minus. Get out the highlighter again. So I have a 3 and a 3. I have a y plus 2 and a y plus 2. So what's ever left over is what we write. So I scratch out the 3, scratch out the y plus 2. So I got a 5 times another 5 times y minus 2. I took that second 5 and put it all the way up front. Okay? Equals. Get the highlighter out. I got a 3. I got a 3. I got a 5. I got a 5. I got a y minus 2. I got a y minus 2. I got a y plus 2. And I got a y plus 2. So it looks like this entire denominator is going to be scratched out. And that's fine. So I'm left over with 2y to the second minus 19y plus 54. Okay? Now from here, we're going to clean everything up. Okay? So I guess what I should have done in this very first term right here, I should have wrote it as 3y times y plus 2. Because now I can distribute. 3y times y is 3y to the second. And then 3y times positive 2 is plus 6y. Now, for the second term here, remember, you got a minus sign out front. So 5 times 5 is 25. So this is going to be negative 25 times y minus 2. So that's going to give me minus 25y plus 50. Okay? Equals 2y to the second minus 19y plus 54. Okay? Now I'm going to group any like terms that I have on the left, any like terms on the right. So I can see right here that I can group the 6y minus 25y. So 6 minus 25 is going to be negative 19. So this is going to be 3y squared minus 19y plus 50 equals 2y squared minus 19y plus 54. And my eyes are instantly attracted to these two terms right here and right here. And the reason why my eyes are so attracted to these two terms, they're quadratic. So I know, set this equal to 0 and then solve. So let's group all my like terms together. We'll do this one step at a time. I'm going to subtract 2y squared from both sides. That's going to give me y squared minus 19y plus 50 equals negative 19y plus 54. Now I'm going to add 19y to both sides. That's going to give me y squared plus 50 equals 54. Notice negative 19 plus 19 is 0. And then finally, I can subtract 54 from both sides. They give me y squared minus 4 equals 0. And notice that all this work, let me zoom out here real quick because I'm kind of chuckling here. I'm laughing. All this work right here funneled us all the way down to difference of squares, which is the easiest one to factor. Y plus 2 times y minus 2 equals 0. Set each one of these equal to 0. And then we can solve, subtract 2 from both sides. Y equals negative 2. Add 2 to both sides. Y equals positive 2. But you know as well as I know, we got to check. So I will rewrite the original problem over here on the right-hand side. I'm going to write its factored form, okay? So let's see, where was that? Oh, it's too far out. That's fine. I could do it in my head. So y over 5 times y minus 2 minus 5 over 3 times y plus 2 equals 2y to the second minus 19y plus 54 all over 3 times 5 times y minus 2 times y plus 2. Now, we need to check. So we're going to let y equal negative 2. And remember, you were looking for denominators only. So, y over 5 times negative 2 minus 2 minus 5 over 3 times negative 2 plus 2 equals 2y to the second minus 19y plus 54 all over 3 times 5 times negative 2 minus 2 and then negative 2 plus 2. Now, I'm going to get out my highlighter because I see something and it's blaring. It's right here. Or did I say blaring? I meant glaring. It's early in the morning for me. So I see negative 2 plus 2, and I know that is 0. So I'm not allowed to have 0 in any denominator. So y equals negative 2, not a solution. Extraneous. Now, we need to do the same thing with positive 2. So y over 5 times 2 minus 2 minus 5 over 3 times 2 plus 2 equals 2y to the second minus 19y plus 54 all over 3 times 5 times 2 minus 2 and 2 plus 2. And once again, I get my highlighter out because I see this. It's glaring, correct word this time. And I know 2 minus 2 is 0. So this goes to 0. Therefore, y equals negative 2 is extraneous. So here's a problem where we legit went through all of this work. I mean, look at this. This is like, I know this is going to sound really weird. Let me center it real quick. This to me is kind of like, it's kind of like listening to your favorite song. Like everything just fits. It all works. And we get all the way down to the fact that both solutions that we arrived at are extraneous. There is no solution to this problem. And like I said, the only way you're going to know is you got to do it and you got to check it. Okay? So the last two examples I'm going to do are just dancing with equations. Okay? So what I mean by that is this. And I got through a lot of my chemistry and physics courses because I could do this. All right. So here's what I mean, okay? We're going to solve f over a equals m for the letter a. In other words, there's no letters. I'm sorry, there's no numbers. The only thing you got to do is just know how to algebraically manipulate an equation. So my goal is to solve for the letter a. That's what I want to do. So the easiest thing I would do is, well, I would look at it and say, well, it's in the denominator right now, and I don't like that. So I'm going to multiply both sides of my equation by my LCD. In this case, it happens to be the letter A. So by doing that, notice that on the left-hand side, the A's reduce. So I'm left with F equals MA. And then since I'm solving for A, I'm going to divide both sides by M. To give me F divided by M equals A. And that's it. So these last couple problems here are just going to be solving for a variable. Nothing crazy. Okay? So let's try another one here. Let's try this one. Solve M equals x minus 2 over y minus 3 for y. All right, so you got to take a step back and look, your y's in your denominator. So the easiest way to kind of get it up with everything else is to multiply both sides by that denominator. So y minus 3 times m is going to equal x minus 2 over y minus 3. But remember, we're going to multiply this by y minus 3. Now we do that so we can reduce on the right-hand side. So now I have y minus 3 times m equals x minus 2. And from here, you got a couple options. But what I'm going to do is divide both sides by m. Because if you think about it, it's the quantity y minus 3 times m. So I'm just going to divide both sides by m. On the left-hand side, I get y minus 3. On the right-hand side, I get x minus 2 all over m. And then finally, I'm just going to add 3 to both sides to give me y equals x minus 2 over m plus 3. And that's it. And that's going to be it for this lecture video. 48 minutes is long enough, I think. So good luck this week. If you've got any questions, feel free to email me. I will talk to you in the next one. Bye.